Hey everyone, I'm Peter from the Firebase team. Our friendly meal sample app uses AI to create amazing recipes, but what happens when you want to save your favorites? Today, you'll learn how to use Cloud Firestore to build a complete cookbook feature right inside the app, from saving and viewing to updating and deleting your recipes. You know, for those times when you need to get rid of those recipes that you tried on your friends and that they didn't really like. The best thing, all data is stored in the cloud, so users of your app will be able to view their saved recipes on their other devices, for example on a tablet they use while cooking. They can even share recipes with their friends. And maybe this is the start of a great new social cooking app. Who knows? All of this is possible thanks to Cloud Firestore, Firebase's horizontally scaling document-based NoSQL database in the cloud with real-time synchronization. Before we can write any data to the database, we need to decide on the shape of our data. I've defined a Swift struct that has all the key properties of a recipe: its title, a description, the cooking time, a list of ingredients, and, very important, the instructions for preparing the recipe. To make sure I can show this in a Swift UI list view, I'll add an ID property and conform the struct to Identifiable and Hashable. Firebase is a document-based NoSQL database. That means all your data is stored in documents, like this one. All the properties on your Swift struct map to a field in the document, and vice versa. Documents are stored in documents collections. This allows you to keep your data neatly organized and managed. In this app, we store all recipes in the recipes collection. To make sure each user can only see their own recipes, we store the user's ID in the recipe documents. This way, we can filter by user ID in our app. At the end of this video, I will show you how to set up security rules to make sure users can only view and edit their own recipes. Firestore can automatically map the document ID to the ID property on a Swift struct by using the add_document_ID property wrapper. And thanks to Swift's Codable protocol, Firestore can also automatically map all properties in your Swift struct to a document and vice versa. If you'd like to learn more about how this feature works and how you can map even complex data types from Swift struct to Firestore and back, check out this guide in our documentation. It provides an in-depth discussion of Firestore and Codable. Now that we've got the data model, we can save recipes in Firestore. First, we get a reference to the app's Firestore instance. Then, we need to tell Firestore where to store the new document. As mentioned earlier, we're storing all recipes in the recipes collection. It's a good idea to define a constant for the collection name, as we will be using this for all the other database operations as well. And finally, we can add the document for our recipe. Thanks to Firestore's support for the Codable protocol, this is a one-liner. Okay, maybe it's a couple more lines if you add some error handling. Adding data to the database is only half of the story. Retrieving data is just as important. Firestore supports two main ways to fetch data: fetching data once, using getDocument or getDocuments. This is great for when you know you will only need to load this data once. But Firestore also has a really cool feature that allows you to fetch data and receive updates in real time. This is great for apps that allow users to access their data from multiple devices or share with other users. To use this feature, you have to implement a Firestore Snapshot Listener for each collection or query you want to observe in real time. Inside this closure, first handle any errors and ensure the query snapshot is not nil. The code for mapping the documents contained in the snapshot is the same as in the code snippet I showed you for one-time fetching. But there is a more elegant way to write this. Here, we're using compact map to iterate over the documents and filter out any documents that couldn't be mapped or that were nil for any other reason. We've now implemented two key use cases: adding new recipes and later retrieving them for showing them on the app's main screen. Let's take a look at modifying existing documents. Users of your app might want to keep track of which recipes they really liked. So we need some way to track the user's favorite recipes. Let's first add a new field to the recipe type in our Swift codebase. You might be wondering why this property is marked as optional. Well, this is to make sure that existing documents that do not include this field can be mapped correctly. If a Firestore document doesn't contain all properties that are declared on your Codable Swift struct, the mapping will fail. By marking this property optional, Firestore will map the document without trying to map any optional properties. Definitely check out that Firestore and Codable guide I mentioned. It provides more details about dealing with different data types, optionals, and mapping properties to document fields with different names. With this in place, we can now write some code that marks a recipe as a favorite. All we need to do is toggle the isFavorite property on the Swift struct, for example, when the user taps the star button on the recipe details screen. Then we get a reference to the document that represents this recipe. And finally, we call setDataFrom on this document reference, passing in the updated recipe. The Firebase SDK will use Codable to map the recipe and update the Firestore document. By specifying merge fields, we can ensure that only the explicitly mentioned fields are written. This prevents accidental modifications to other fields that the user might have changed from their other device in the meantime. Finally, let's implement deleting documents. Again, we first need to get a document reference. Deleting a document is just a single call to the delete method and poof, gone is that recipe none of your friends really seem to like. And with that, we've finished implementing a complete create, read, update, delete feature for recipes. Let's take a look at what we've achieved. Here, on the main screen of the app, you see a list of recipes that I added earlier. These are fetched from Firestore using the Snapshot Listener we implemented. I can use the swipe actions on the list to either mark recipes as favorites or delete them. Let's see. Everyone loved the Parmigiana we made the other day, so that's a clear favorite. And then, nobody really seemed to like the Lobscoes I made for them. Weird. So let me delete that. Okay, but that means I need something else. Let me generate a new recipe. I think I might have some cauliflower, lentils, and coconut milk at home. So let's see what the app comes up with. Cauliflower lentil curry. That sounds great. Let me add that to my cookbook so I can try it out once I wrap up here. But before I let you go, there is one more thing you should definitely do. Please write security rules for your Firestore database. This makes sure that only authorized users of your app can access the data they own. At the very least, you should implement security rules that make sure only signed-in users can read and change their own data. Here are the security rules for the current data model of the app. As you can see, only signed-in users can create new recipes, and they can only view, update, or delete their own recipes. And that's a wrap. You now know how to store data in Firestore using Swift's Codable protocol, how to listen to real-time updates using Firestore Snapshot Listeners, and you've seen how to update and delete existing documents with just a few lines of code. For more details about Firestore, check out our documentation. Also, be sure to check out the Get to Know Cloud Firestore video series for more details about data modeling and some advanced topics such as transactions and batch updates. Don't forget to subscribe to the Firebase channel on YouTube and give this video a thumbs up if you learned something new. Thanks for watching, and I will see you in the next one.